Welcome to our first Have Fun episode. My name is Andrew.
And my name is Christina.
I'd like to show you a cross-platform mobile project written in Kotlin, on Java platform.
There should be no problem for Android. But how can you make it run on iOS?
I use a tool called RoboVM. It translates Java bytecode into machine code with the native iOS API support. Its classes are based on Android's runtime.
Sounds great.
You can register to get a trial license key on their website. Let's get started. Our Have Fun project is called TumChatter. You can find it on GitHub at the link above. Now, let's have a look at the major tools and libraries that are used in this app. We target only Android and iOS. We use Android Studio, but we also tried IntelliJ. It works fine too. As mentioned before, we write this app in Kotlin. It's a new programming language from JetBrains. It's part of our fun.
You're too slow, Andrew. Let's show them all.
Okay, young lady.
That's better.
Let me explain something quickly. Only KotterKnife and ButterKnife are Android specific. They're used for user interface binding. However, all the other libraries are used for both iOS and Android.
Cool.
TumWeb is our little fun toy. Currently, it provides only a very basic MVC web framework, running on top of Nanohttpd.
You didn't miss to mention our own toy.
Not a chance. Now let me show you how install the plugins. Open the Preferences window. Then select Browse Repositories in the Plugins section. Search for RoboVM, and install it. If you haven't had Kotlin installed yet, please install it as well. Then restart your IDE. After that, we're ready to go.
Fantastic.
Let's browse the project quickly after we open it. Here, besides Android, there are other configurations for iOS. We'll try this iPhone 6s simulator. Click Run. While it's building the app, let's watch the sunset together with Chris and me.
You're such a romantic.
It's about to finish. The iOS simulator is now being started. The app is now launching. And it's waiting for an input. Let me say hi to someone there.
Holy shit. It works. Andrew, are you really talking to someone there?
Not really. This is just a demo chat application. It connects to the web server application embedded inside this mobile app.
Whoever, or whatever you're talking to, seems to be very cautious with a stranger.
Maybe just a little. Anyway, next, I'm going to show you what the app looks like on the Android emulator. As you can see, the Android looks pretty similar to the one on iOS.
Yeah. Both of them look equally plain.
Thanks, Chris. In the project file structure, there are 4 app-specific folders. Apparently, the Android and iOS folders contain the code specific for each platform. The mock web application resides in the mock folder. The core folder contains the common code that is shared by both iOS and Android apps. It also contains the code that is used to interact with the other 3 components. Let's have a look at these components in more detail. In this app, we use a pattern that consists of several different elements. The first element, or the presenter in the core module, contains all the UI logic, and it handles communication between the view and the model elements.
Can I be a model?
Of course you can, Chris. Anyway, we reduce the responsibility of the controller in iOS and the activity in Android to just handle the platform-specific user interface bindings, with no presentation logic at all.
How does the presenter talk to the controller and the activity?
Both the controller and the activity implement the view interface. The presenter communicate with them through this interface. However, the controller and the activity can talk directly to the presenter, as well as the model provided to them by the presenter for data display.
Why do we have to do all this?
The objective of this pattern is separation of concerns. Not only does it allows us to share the core module in different platforms, it also make the code easier to test and maintain. Next, we're going to show you some amazing stuff that RoboVM provides. Let's try adding a breakpoint to this line. As mentioned before, this is the code written in Kotlin. I'm going to type something and send it using the iOS app. Now the execution stops at the breakpoint position. Let's find out what we can see in the debug window.
Wow. Cool. We can see the stack frames and the variables, like the other Java or Kotlin apps.
Yeah. That's pretty cool. Now, let's try forcing the app to crash by manually throwing an exception.
I feel excited to see it crash.
Okay. You'll see it soon enough. Just give me a few more seconds. Let's go back to the IDE. It looks like the app has stopped now. The exception has been reported in the window here with the stacked trace. We can click on the source file name and it'll take us to the call position in the source code as usual.
Fantastic.
We'll finish our presentation with the unit testing demo. Let's start from the results first. Here you can see that the test results looks quite different from the usual ones we're used to.
They look quite clear and readable to me.
I agree. Let's see the actual unit test code. We use a specification framework called Spek.
I could not think of any better name than this.
Yeah. With this framework, tests now become executable specifications. We describe the behavior we need. The framework helps encourage human-readable tests. There are also two other useful frameworks that we use in these unit tests: Mockito and AssertJ. Mockito facilitate the creation of mock objects and also allows us to verify the behaviors. Unfortunately, when is a keyword in Kotlin, so it needs to be escaped with backticks. I create an alias for it called uncalling.
What's the other framework that you use?
It's a fluent assertions framework for Java called AssertJ. It can be used in Kotlin as well. It can really help make our test assertions more readable.
Wow. All these frameworks could really make writing tests a more enjoyable experience.
They certainly could.
We hope you enjoy our demo and presentation.
Thanks for watching.
See you next time. Andrew, do you think there's anyone still here?
Everyone seems to have gone.
Okay. Let's fly home.
Wait a second. Just in case there's someone here. Thank you again.
Thank you and goodbye.
Goodbye.